Hello, everyone. Today we are here to talk about BOSH. And here is my name, and Twitter, and email, company Twitter, company website. So I'm Benjamin Gandon, CEO of GStack. And GStack, we will talk about it just in a minute. Formerly, I was a developer. I was a Java architect, and then Java CTO. And as an operator, I organized my team as the most radical way of being DevOps, which is you build it, you run it. And it was a pretty efficient organization, which I was very proud of. But I wanted better tools for production system for such good organization. And I wanted to revolution devs and ops lives. So GStack. GStack is about we do consulting, independent from any software vendors. And we have a special interest in container technologies in general, which I call superstructure. You might not know what is a superstructure because I invented the term. And we will talk about that just in a minute. And we have a special focus in Cloud Foundry, Concourse, and BOSH technologies. We invest research into 100% open source Cloud Foundry. And we run a public platform on which you can go and register. It's buddies.gstack.io. Superstructure. What coined by GStack. So starting with VMs and networks, the idea is that this is your infrastructure. And usually you run things on such infrastructure. But nowadays, and this is AWS, bare metal, OpenStack, or CloudStack. But nowadays, we build container hosting structures. And that's where you are going to run your workloads. These are superstructure, because it is an infrastructure, but above the infrastructure. So I call it superstructure. And this is Cloud Foundry, Docker Swarm, Kubernetes, or Mesos, you name it. There you run your workload containers, and they are running on top of Docker or any OCI compliant technology. I don't like middleware, actually, because middleware means anything. So that's why I call it superstructure. End of the parenthesis. So we hear about BOSH. Why do we care about BOSH? Let's take a step back and see the big picture. So we are going to talk about organization. And then we will talk about tools. And there's a good reason for this, because we are in France. And in France, most companies need to really improve in the organization field, more than tools. So, traditional organizations. On one side, you have developers, and on the other side, operators. Developers they get business requirements, and they ship binaries to ops that put them into production. In this context, developers are responsible for making systems evolve, and operators are responsible for having those systems being stable. This is just the opposite. So, of course, we have frictions. And developers face market pressure, and operators are facing crisis management, laborious debugs, late hours. So devs requests, they pile up, and they say, what's the matter? Operators are not reactive, and operators, we are not aware of that. Developers are not organized. And everything becomes urgent, So operator says, developers, they make the production at risk, and they are shipping buggies and float binaries all over the place. Anyway, how do we get out of this situation? We need to better collaboration and re-establish trust between teams. So we have them work together, we break walls, and we establish visual management boards so that they share common goals, see how they do things, and start to say, they're actually doing a good job. You too, thanks. And we also have operators participate in the project backlog upfront when developers get business requirements. Otherwise, the operators' work is always underestimated. So they start talking because they are working together now. Guys, what if we were improving our tooling? Yeah, but the good question is, what do you need, you guys? And yeah, we need something that we put our code into and it makes working application platform-ready. Right. And we, as operators, do we need tools too? Yeah. Look, we are using Git, and it's really efficient when it comes to tracking, versioning, things that are changing. Right. And we also use integration systems. You should think about that. Oh, yeah. It reminds us about infrastructure as code. And there, the good questions start to arise. Infrastructure as code with Ansible or BOSH. The important thing is that we finally establish a self-service IT where developers take what they need without needing the operators to do it, and they don't slow down operators with low added value tasks. And this is a revolution. It's called DevOps. And it's not new at all. Not new at all. And nowadays, we have a refined version of DevOps, which Google published 1 year ago in this book. And it's called Site Reliability Engineering. And some companies are already into it, like Criteo here in France. It's about Google implementing DevOps. And it gives many hints for companies that are not already into DevOps and helps them to focus on the right thing. And maybe it's DevOps version 2, somehow. Anyway, we talked about organization because we are in France, and that's more important here than anywhere else. And now we can talk about tools. That's where, and tools. For developers, the self-service IT would be, I need self-service containers so that I can write my applications and not focus on anything else. So we start to say to our developers, you write your code, you push it, and then something comes into play. And what happens? You get a web application. Take your web browser, put your URL, and oh my God, it's working. There you need CloudFoundry. And usually we don't CF push directly. We use an integration, continuous integration system to do it. We just git push our code. And that's where we talk about Consul plus CloudFoundry as tools. And self-service IT for operators is for industrializing systems management. And you say, now you write your deployment. Just describe the infrastructure that you need. You BOSH deploy, something comes into play, and there you get something that's working, namely CloudFoundry. And that's where we talk about BOSH. And we're not using BOSH for only deploying CloudFoundry. Following the same pattern, we can deploy Concourse CI, working one. Actually, we can deploy anything with this, with BOSH. So, to summarize, self-service containers, CloudFoundry, integration, continuous integration, Concourse, and deep automation and orchestration, BOSH. just a bit more introduction about cloud computing, and let's talk about pets and cattle. Thanks to Gavin McCance, who coined pets and cattle, I have my own version, because here in France, we are not used to those two terms, pets, cattle. Actually, pets, c'est les animaux de compagnie, en français. And they are given sweet names, like Albator or Goldorak. And they are unique and lovingly hand-raised and cared for. When they get ill, oh my God, it's a catastrophe. We have to rush and nurse them back to health. Because they are so cute. And cattle, c'est le bétail, en français. They're given just numbers, because actually we don't care. They are most identical to each other. They are nearly clones. And when they get ill, you kill them and get another one. It's cattle. And this is another revolution. It's called cloud computing. And actually, when my mother says, oh, cloud computing, it's Dropbox, I said, no, it's pets and cattle. This story. And in real life, why do we care about that? Because we want to sleep at night. And we are not sleeping at night because we are watching pets that die at night. Oh my God. And this is preventing us from sleeping. Whereas with cattle, if one fails, we are not awakened at night, so we can sleep. That's why in real life, we care about cattle. We want cattle. We want cattle. We want cattle everywhere. And there comes BOSH into play. So BOSH. BOSH deploys systems. Right. So here is my BOSH server, and it deploys a system. That's an application, let's say, running on a virtual machine. Right. And BOSH deploys distributed system. Okay, it's not about one application. It's going to be several applications working together with different responsibilities. BOSH deploys and manages distributed systems. Right. So those systems, when they are up, they're going to talk back to BOSH and say, hello, I'm there. BOSH is going to say, right, cool. But if one fails, it's going to say, wait a minute, there's something wrong here. I have to bring it back up. So it manages systems. And BOSH manages large-scale, deploys and manages large-scale distributed systems. So it's not about pets, it's about cattle. And hey, look, mommy, I'm running a cloud. So BOSH. First, let's talk about the name, because everyone here is wondering, why the hell did they choose such a bad name? And I must confess, even for Americans, it is a bad name. Because when you Google it, you get, did you mean BOSH? The drillers and the tools. Anyway, I couldn't resist. Hi, General, I heard about BOSH. But what is BOSH? BOSH is BOSH outer Those bloody Americans, they find it funny to invent recursive name. So, it's not the rename, actually. The rename, we had the real answer. It's Borg++. So Mark Lokowski told us, influenced by Google's Borg, and it's Borg++ because R+1 is S, and J+1 is H. And you might not know Borg, but it's the cluster management tool. And a cluster at Google is one main cell with 10K servers. It's a big thing. And they didn't say it 8 years ago that it was an open source Borg, because Borg was the system who must not be named. It was a secret technology inside Google, and nobody were allowed to speak about it. So those guys coming out of Google, they started again a similar project, and they had to name it differently and never say it was coming from Google Borg. And until 2 years ago, because 2 years ago, Google published publicly something about Borg and started to talk about it. Anyway, what is BOSH? BOSH drives an infrastructure as a service, a IaaS. And it's exactly like a laptop that is driving a printer. In between, you have a driver translating instructions to the printer. And it's exactly the same for BOSH, which drives an infrastructure as a service, a cloud. In between, the driver is named a CPI, a cloud provider interface. But the feature is just the same. It translates orders into what the infrastructure can understand. What does it mean? So, no. First, what is a IaaS? So, you know many of them. Some are open source, like Apache CloudStack, OpenStack, RakeHD, which deploys bare metal systems. And you know the proprietary ones, AWS, GCE, Azure, and vSphere, that you can install at home and not only use publicly. And what does the IaaS do? For example, it creates virtual machines. It attaches persistent disks to virtual machines so that you don't lose your data. It implements networks that you have to set up, and it can resize a disk. And the cloud provider interface is responsible for driving the IaaS to do that. Good news, you can have several of them per BOSH server. So you can drive many different IaaS in the end and say, some of my infrastructure is going to be on AWS, some other part is going to be on GCE. Interesting. BOSH deploys systems. What's going to happen? My command line is here on my laptop. Hello, it's me. And on the other side, there's an infrastructure, which can be controlled through its API. And in between, the BOSH server. The command line talks to a component, because the BOSH server is a bunch of microservices. So one of them is called the director, and the command line talks to the director, which delegates the controlling of infrastructure to the CPI, which drives the infrastructure. Now, we tell him to deploy something, so it's going to deploy something. Create VMs, and when they boot up, they are executing the BOSH agent, which in turns talk back to BOSH. And BOSH says, oh, right, you're up. Now you're going to run workloads. And it distributes binaries and processes to the VMs. Then the VMs are running, and they say, I'm there, I'm running fine. And the health monitor is monitoring that. If any VM fails, one of its plugins is responsible for bringing them back up in case of failure. Okay. And BOSH compared to other tools, you might have known of Chef, Puppet, Ansible. Let's talk about that. BOSH is much more than configuration management like Chef or Puppet. It provisions the infrastructure, controlling resources efficiently. It rolls updates, and with a proper order, minimizing disruptions. Just have to say which version you want, it does it. Don't have to code anything. And it does update only what's necessary. Release engineering. BOSH proposes an open structure and lifecycle for release management, and provide all the tooling for that. It's incremental. You iterate when you create the BOSH releases, and it's fingerprinted. Only what has changed needs to be changed. And it rolls operating system updates, which is not an easy task with usual tools. Like, you just say, I want version n+1. Do it. Don't want to know how do you do that. And actually, it's going to recreate every node and recompile software that needs to be recompiled. It also has recovery mechanisms. We just talk about that. built-in, detect potential problems, like failing services, and inconsistent states. And Ansible. You might have heard of Ansible. Who has heard of Ansible? Yeah. So it's a good tool, but it's imperative. You have to say, do this, do that, do this, do that. And it's scripting. So you code. And you code, it's specific to the target where you deploy. AWS or GCE, it's specific. And when you roll updates, you have to code how to do such things. With BOSH, it's descriptive. You just say, I want this, do that, and do it. I don't want to know how. So it's deploy framework tailored for 24/7 cloud services, target agnostic. Do it for AWS, it's the same, and you don't have anything to change. You can run it on GCE. And for running updates, just have to say, now I want version n+1. Easy as that. For example, with Ansible, I have an etcd cluster. And I want to deploy an etcd cluster. So I'm going to write some Ansible code. Right. So, and now I want to scale up. That's not the same use case. I need to write some more code. And I need some more code and more code. Now I need to scale it down. Ah, crap. Didn't thought about that. I need some more code. Upgrade versions, more Ansible code. Upgrading OS, guess what? More Ansible code. And for any other cluster, it's nearly the same, but it's not exactly the same. You need, guess what? More code, etc., etc., etc. And now, we do that for AWS. We want to go to GCE. Oh, crap. It's kind of the same, but we need different code base. This doesn't scale the proper way. That's why we use BOSH. So what do we need to run BOSH? Our BOSH server, we saw that earlier, is going to deploy VMs and processes on those, make deployments. What do we need to have such results? First, what are the compiled binaries that we are going to deploy onto VMs? On which base OS image, which operating system, and how are we going to lay out those things onto VMs? So first, we need to upload a BOSH release into the BOSH server so that we specify which compiled binaries. We need to specify a stem cell. What is a stem cell? A stem cell is an unspecialized cell. It's an image. So it's unspecialized, and it's going to be specialized when BOSH will tell it to do this or that specific task. So it's just an operating system, actually, and a BOSH agent, like we saw it earlier. And the layout of those things is described in the deployment manifest, which is YAML. There's another configuration, cloud config, where we specify cross configuration that are necessary for any deployment, like networks, VM types, and disks. That's it. So, deployment manifest. Because the first time you will use BOSH, you will actually use an existing BOSH release and try to deploy it. So you need to write that deployment manifest that tells which binary is going to be deployed on which VM. They are always organized the same way. You see one deployment manifest, you know every deployment manifest. First, you have deployment information, like its name. You specify the operating systems through the SAM cells, the versions you're going to use, and the kind. You specify the binaries through releases. Here we need a Redis binary of that version and a web binary of latest version. And you specify how BOSH is going to deploy this, how to update those, how many at once with the max in flight, and waiting for how much time for it to boot up properly. Then you describe that layout, instance groups. Instance groups are just clones of the same instance. Here we have one instance of Redis server. We say we want one instance, and it's going to run on Ubuntu operating system. We just have to write that, actually, to get it. And it's going to run the Redis server job, which is composed of binaries and runnable process, and it needs configurations. So configuration that we are going to add to this deployment manifest. For example, we deploy here an instance of database, which is made of MySQL binaries, and we need to configure it with, for example, username, password. Well, okay, right. Why do we put in a username and password? Where does it come from, actually? It comes from the BOSH release, where we have packaged the binary, the software at first. There's a specification file for that job, MySQL job, in which we say that we need properties like username, password, we describe them, and we also need a port. But actually, there's a default value, so it might not be necessary to specify it. Then, what are they going to be, where does it go? It goes to a template file like this, which will produce the famous myCNF file that configures MySQL and tells it how to run. Inside this, the username will be injected, the password, and the database port is coming from the default value. That's how, in the end, configuration properties are specified from the BOSH release, and finally comes down to the deployed VMs configuring the processes that are going to run. And wait a minute. I'm deploying a database, but I'm also deploying a web application. And the database has a username and password, but the web application needs that username and password to connect to the database. So are you saying that in my manifest, I need to push the passwords twice, one for the database and one for the web server? Actually, no. Actually, no. And this comes from the release. In the MySQL release, we're going to say that we provide some configuration, like username, password, and port. And in the web server release, we're going to say that we consume those configurations. So, in the end, in the deployment manifest, what you will use for your first experience with BOSH, you really don't need to specify those configuration twice, only once. And it gets automatically wired to the other place where it's needed. Let's do a demo. So, I have a running BOSH server in which I have uploaded BOSH releases, namely Consul in version 2.7.4, and Gandon runc. It's a dependency for Consul. And I have uploaded an Ubuntu stem cell of that version. It's changing every week, actually. So that's why it's 3,000 and something. And I also have a deployment manifest. It's actually there. We're not going to dig into it, but it's describing how the layout of the concourse deployment. And with my BOSH command, I have targeted. So I just need to say BOSH deploy. And it's going to say, is that what you want to deploy? Yes, that's what I want to deploy. And it's going to do it. So is it working? Yes, it's working. So this could be any web application, actually. It happens to be Concourse, which is a contiguous integration system. So we have a login here. What was it? It might be specified in the manifest. Okay. Oh, GStack rocks. Right. Okay. GStack rocks. So here we are. It's a new deployment, so I can use that. Actually, I have, and I can push things into it. GStack rocks. Okay, and now I can push something into it. Right, this thing. Okay, and I can run it. Actually, unpause it, and it's a system that can be triggered. So let's trigger it. Is it working? Yes, it's working. So it's actually doing things, no matter why. Let's talk about how we package software to get such nice results, like just describing what we deploy. How we package things to get such nice results, like just describing layout of things, saying BOSH deploy, and just that. So release engineering. BOSH releases. Actually, they are made of just few things. First, source files plus blobs. Actually, source files are going into a Git repository, and blobs, well, they are big binary file like tables. You can put that into a Git repository. But so they are put into like a blob store, like AWS storage. Then it's packaged into BOSH releases, and that is deployed. What is the structure of a BOSH release? Actually, there are three important folders: sources, packages, and jobs. Into sources, you say the source code that you specify the source code that is going to be used by working applications. Into packages, you explains how you compile that source code, and into jobs, you explains how you're going to run those binaries so that you get live processes onto your machines. Well, sources. Let's say we want to deploy a Golang application. You know that. Okay, we need to specify sources plus blobs. Why? We have those sources for that Golang application. So it's those files, and BOSH is going to need a Golang binary so that it can run and compile and run the Golang sources. So it's a big table, and it's going to be uploaded into an Amazon S3 blob store, so that in the end, you don't ship those big table files into Git repositories. So all in all, you specify into the BOSH release, into those files, your source code, and into config blobs YAML, you specify how you will get those big tables that are needed. Then, into package, remember, we specify how to build the application. So this is a shell script that explains how to build it. And you will run the Golang binary to say, go build those source files, which means that we have, when we execute that, we have the binary of Golang that is already there. We'll talk about that just in a minute. And jobs are about how you run these. So it's another shell script that exports some environment variables, creates a PRD file, and just executes my application, just the last line, changing the user with chps3. That's just it. We are just running a binary, and it's going to be a live process. So when you upload a BOSH release into BOSH server, it's going to compile it. And that's an important step to understand. On one it will create one VM for compiling this, each package that has to be. And if something depends on some other package, it's going to provide it into the compilation VM. Namely, just before, it's going to provide the Golang binary so that we can compile our Golang sources. Then all those go into a blob store, which is an object storage, where we snapshot all the results of those compilation. And into this blob store, BOSH has everything to bring anything back. If anything fails or anything is no more there, it just takes what is required into the blob store and recreate VMs, recreate processes, and that's how it does. And the workflow. So you create a release, you upload it into the BOSH server, you edit your deployment, saying how you lay out things, and deploy, so that you can test the results. And this, you're going to do it many times. It's iterative and adapted to agile deployment. The first part is about BOSH release, and the second part is about deployment manifests. And about versioning, you will iterate with development versions until you are fine with it and say, oh, that's a good one. Let's cut a final release with this, and you will iterate like that. So cutting final releases is that command, BOSH create release final with the version. And when you finalize the release, you bring it all together into a big table file that you can upload into a server. Let's do another demo about that. So my BOSH release was properly uploaded, deployed, and the web application, no matter what it is working. And let's say we want to modify it and redeploy it. The thing is, we're gonna add some nice colors to it. So here we are. It's already added. We added those two lines that are new, and we are gonna repackage the BOSH release. So So we create a new development release with those special versioning with the plus, dev, 1, etc. It takes some time, and it's going to find packages that have not changed. Here is the second development version. So we upload it to the BOSH server. And in our deployment manifest, we now say it's not that one, but the latest available one into the BOSH server. So the release is uploaded. Now we have it. BOSH releases. We have it there, and we just need to run our deployment again with the latest version. So BOSH, deploy. And it's going to say, wait a minute, you changed that version. Is that really what you want? Yes, that's what I want. And here it's going to update the instances where things have changed. Actually, there are dependencies, so it's going to update all the 3 instances that have been deployed. But the main one is ATC, which is actually the web interface of the Consul system. That's why it's going to take some time here.
I'm thinking, since I'm quite into microservices, but still it's not such a common practice in most companies, I would say that most of the architectures you're dealing with your clients are more around the theme of SOA or service-oriented architectures. Would you expect in a team of 12 developers for everyone to be knowledgeable with BOSH and these things that you are showing us? Would it be something that everyone in the team is supposed to learn and to use on a day-to-day basis, or is it more like something dedicated to a team of experts who will be animating the DevOps practice in the team?
It depends. Actually, you can have a team with all the knowledge required to build the applications, and some of them are being experts into BOSH and actually running the release management and creating those BOSH release, and with the time explaining to others how they do. So, and for bigger organization, you might have a dedicated team to that. But I'm in favor of spreading the knowledge across teams. So every team should have at least a bit of knowledge of BOSH and knowing how to do it. So we said we wanted to add nice colors. Here they are. And my colleague comes and says, hey, Benjamin, are you aware that the boss actually hates cats? Oh my God. I need to roll back because the boss hates cats. So let's back to the former version and say, well, wait a minute, I want to go back. And BOSH I say, BOSH deploy. He says, you want to go back to latest version? Yes, I want to go back to it. And here it's quite fast.
Yeah, when you're doing the rollback, is there, what happens with the server that's up and running? Is there any downtime, or is it seamless from one to the next?
Doing the rollback, the VM is not bring down, but the process is stopped. The web process is stopped. The binaries are replaced, and the new binaries are re-executed. That's where you need to have many of such instances, so that only a few of them are brought down at the same time, and the service keeps being served. Actually, here we have an example deployment with one instance for the web process, but when we have many, then we have no downtime deploy. So the question is that something that we can orchestrate with BOSH? And yes, actually, it's a built-in feature. We just have to say that the max in flight is small enough not to bring everything down at the same time, and the remaining up systems that are up will serve the requests. So we are back to it. Thank you.
Que la famille.